Hello everyone, welcome to the Audio SoC Framework Introduction. Today we'll go over these following topics. So, our current framework is 1.5/5. In-out, next one will be 1.56. The O is what we do support. As you see, the left column shows you what features we currently support. So we support all these Bluetooth profiles in the current version. On this slide here, we list partial audio features. We support all these audio features in both versions. We continue to list the remaining audio features. And note that audio plugin will be supported in the next version. On the next slide here, we have some more audio features. Along with remote features and console features, it's important to note that these features are the full software capabilities of our SDK, and you should consult Realtek about supported features for different IC types. Here's a list of product features. And like the feature list before, you should consult Realtek about support product styles for different ICI types. Next, let's talk about the architecture. On the top in blue is the application layer, and it interacts with the framework through a series of API calls and callbacks. And for some layers, they will access even lower layers, such as the transport layer or Bluetooth stack if needed. And if you take a closer look, these arrows are unidirectional, so you will use API calls for the application layer to communicate to these framework layers. And these framework layers will use callbacks to respond. This communication methodology won't change, so you don't have to worry about that. In the middle is the system manager, which is the main control module. This is the first module to get initialized when the framework is initialized, followed up by other function modules like the BT manager, audio manager, etc. Next, go more into the system manager. As I mentioned earlier, this system manager is the main component of the framework, and it provides the internal fundamental utilities for other components and provides the public version information and power control. So as the main component of the framework, before using another module, the system manager must get initialized first. The system manager is split into public and internal components. The internal components will be invisible to the application layer, so you don't have to worry about those. The public components compose of the version, which is for the application layer to link with libraries, and the power manager, which allows you to power on or off. So now we have the BT manager. The BT manager provides three main features: a profile manager, link manager, and sniffing manager. These provide classic profile APIs, BR, EDR, ACL, SEO link key, and power control APIs, and audio and voice sniffing link control APIs respectively. BLE isn't in the BBT framework module, rather it's supported in the libraries. The BT manager then interacts with the Bluetooth stack, abstracting out those details for you. Following that, we have the audio manager. So at the first layer, we have audio-related functions. Starting from the left, we have audio track and line-in. They control the data flow from the framework to the hardware. Audio track gives you the APIs to control this data flow. Next, we have ringtone, voice prompt, and TTS, which are all notification-related functionalities. Then we have sound processing-related functionalities, VAD, ANC, and APT. The fourth one is sound effect related: EQ, NREC, WDRC, and sidetone. The fifth is volume, which obviously controls volume. Underneath those five are the main modules: audio manager, audio path, audio route, and audio hell. The audio route can be configured by customers. There are two ways of doing so. One is by using the MC config tool, and the other is configuring the audio route API directly. The fourth module we have here is the remote control module. Remote control is used for products such as ones that use TSE or need a P2P connection. Remote control provides two main functionalities. One is the message relay APIs. So the synchronous and asynchronous relays, and the other is role swapped. So you can swap between primary and secondary. Below these two functionalities is the remote protocol, which customers won't have to worry about. The most you'll have to worry about is the payload, or the message that is being sent. The remote protocol integrates with the remote transport layer, which uses the BRTR ASAR link to communicate. This could be changed to a BLE link in the future. It can even be adapted for USB. The last module is the console. It provides two different modes, string mode and binary mode. For either mode, you would have to register your own callback function. This registers it to the CLI core, which then passes through transport adapter and then through some connection interface. You can write a message that will be received by a dongle app, an auto tester, or perhaps a terminal. Should you require a more in-depth look into the API itself, we have a framework section in our documentation, and under it are some of these frameworks that I talked about today. Thank you for listening and have a good day.